In this video, we continue our discussion over chapter 26 by looking at nutrients. So here, nutrition in itself is the study of the means by which living organisms acquire the nutrients they need to grow and sustain life. And a nutrient is just any ingested chemical that's used for growth, repair, or maintenance. There are some chemicals or nutrients that are considered essential, and those are the ones that can't be synthesized by the body. This includes minerals, most vitamins, 9 of the amino acids that are used to make proteins, and 3 of the fatty acids associated with triglyceride formation. Now, as we categorize them, we look first at what are called macronutrients. These are carbohydrates, lipids, and proteins. We spend much less time in this class looking at micronutrients, which are vitamins and minerals. So for each of the macronutrients, I'd like for you to have a good understanding of what kinds of foods they come from and what their functions would be in the body. Now, the idea right here is that carbohydrates are metabolized rapidly, and the idea is that most carbohydrates are going to be broken down into glucose for use within the body. The brain alone needs 120 grams of glucose per day, and so your recommended daily allowance of 130 is mostly made up of what the brain needs. Our cells use carbs for a lot of different things. You're building cell membrane proteins and carbohydrate-based lipids with glycoproteins, glycolipids. It's also going to be important for the formation of ATP as well as nucleic acids. You have a sugar in the chain for both DNA and RNA. You can convert them into amino acids and fat when they are in excess. And the primary function that we will look at is going to be energy source, right here where glucose gets used to make ATP. You can obtain them from a number of sources. Sucrose from sugarcane and sugar beets, fructose from your fruits and honey, maltose from starches in a large amount, and then of course lactose from milk. So with fiber as well, fiber is actually in the category of carbohydrates, and these are going to be types of fibrous materials. Often cellulose is considered in this category, and the idea is that fiber actually can't be digested, so it ends up forming bulk and it attracts water and gives some solid consistency to feces within the large intestine. There's 2 major categories of fiber. There's water-soluble fiber, and the idea here is that this is what's actually seen in lots of things like oats and beans, and that tends to help mix with water pretty easily, and it has been shown to reduce blood cholesterol, very closely tied to low-density lipoprotein or LDL levels. Your insoluble fiber is the one that's mostly associated with bulk, and this is what tends to be associated with plant roughage, like what cellulose is forming. So the idea here is it doesn't really have much of an effect on cholesterol, but this is where a lot of water is attracted to here. So, of course, the second big category we're looking at are lipids. So this is making up about 20 to 35% of your total calories. Of course, your body can adapt to metabolizing other things whenever lipids are depleted to some extent. But the idea here is that you want to make sure that no more than 10% is saturated fats because of the effect that those can have on cardiovascular health. So, of course, fat is really important for body stored energy. It's more compact than carbohydrates, so you can store more of it. Triglycerides are pretty easy to break down, and so they're a major energy source of liver cells, hepatocytes, and skeletal muscle. And then, of course, they're important for a lot of things associated with nutrition. So, for example, you need vitamins, fat-soluble vitamins, A, D, E, and K, need fat in the diet to be absorbed. They are associated with the production of bile, which is vile, but that's obviously a typo right there. So we can actually correct that just real quickly here in the PowerPoint. Bile, not vile. See, much better. It's magic. And then, of course, when you're looking at sources of lipids, there's saturated fats, unsaturated fats, and essential fatty acids that we take a look at. So most of you guys are taking nutrition courses, and so I don't spend a lot of detail looking at these nutrients, but I do just want you to have a general idea of what carbohydrates, lipids, and then the proteins, of course, are and what they're for. So we will keep going here to look at what I think is most important for this class in terms of lipids conversations, and that's cholesterol. So we talked about cholesterol a lot in this course. We talked about how it is the structural basis for bile salt, how it is the precursor to steroid hormones like testosterone, and how it's important in the formation of plasma membranes and the generation of vitamin D. About 15% comes from the diet, but the liver is responsible for the majority of your production of cholesterol itself. And so the idea here is that whenever you look at somebody who has higher or lower cholesterol levels than the normal population, very much of that is associated by what the liver is doing. And so individuals who limit their cholesterol intake can't really change how the liver is producing cholesterol in itself. And so that's usually when medication is needed. And so the transport and the usage of cholesterol is really important, and there's several molecules that are associated with that. We're looking at chylomicrons and lipoproteins to transport all of these through the blood. Now, we've seen chylomicrons before. Chylomicrons themselves look about like this. They are a very high content of triglyceride, because this is what was going to help you bring triglycerides basically from the small intestine into the lacteals and then head to the liver. So there's a really high fat content with each of these chylomicrons and a very low percentage of protein, which is what you guys see here with that little blue structure. Now you'll see a few others that are actually generated here by the liver, and that's the VLDLs, which stands for very low density lipoproteins, LDLs for low density, and then of course HDLs for high density lipoproteins. If you take a look at them, the density aspect is referring to how much protein makes up this particular lipoprotein. So the VLDLs have the highest amount of fat and the lowest amount of protein. LDLs, which are actually formed from your VLDLs right here, tend to have a slightly larger amount of protein than the VLDLs do, but they still have a lot of cholesterol right here, as you can see, and a lot of fatty acids or triglycerides. It's the HDLs which have the lowest cholesterol content and have the greatest protein to fat ratio of all the different lipoproteins that you're studying. And so this ties in with their functions. The idea here is that your VLDLs, right, and the LDLs themselves are transporting cholesterol through the body for use and for storage. So the idea here is that your VLDLs transport these triglycerides to the liver, and that's one of the places that you can begin to store cholesterol and fat in themselves. And that's where they become modified to make VLDL into LDL. And so then the LDLs go out and they're continuing to transport all this cholesterol that you can see within them all throughout the body. And these are the guys that you look at that if they're really in higher concentrations than about 130 milligrams per deciliter, these are the ones that can start to cause the formation of plaques and get stuck in blood vessels. So these are the ones that are associated with heart disease and a lot of other maleffects. The high density lipoproteins, on the other hand, with their very high protein content, are actually doing the opposite of the LDLs. They're taking some of that excess cholesterol from peripheral tissues and returning it back to the liver so it can be metabolized and removed. And so you want to make sure you have higher levels of HDLs. And so looking at RDAs here, you're basically seeing that about 40 milligrams per deciliter or below is undesirable. You want at least about 60, based on what I last saw, to make sure you're protecting against heart disease. So do you have an idea here of what those lipoproteins are and the chylomicron is and what they do? And just showing you a basic schematic of how they work. Once again, it's the chylomicrons here that take all of the triglycerides from what you've eaten and they absorb it into the lymphatic lacteals and they transport all of that back through the venous system, through the blood, right? And then finally to either adipose or to the liver. Now, lipoprotein lipase right there is an enzyme which helps to pull those lipids away from the chylomicrons so the lipids can actually be stored in adipose tissue or so it can be metabolized and used by the liver. Now from there, the liver itself making your VLDLs, which are then transporting all those triglycerides and they're storing them and using them in different places. And once they've done that, the VLDLs become LDLs, but that still has a pretty high cholesterol level. So as it continues to circulate through the body and bind to cells to drop off its cholesterol, it can get stuck. So at the same time, to combat this, the liver is producing the HDL shells, and as it mentions right here, those are empty initially. So as they circulate, they pick up cholesterol molecules and return it to the liver for elimination or production of other metabolites. And so you see that really low cholesterol concentration there in the HDL. The last macromolecule we look at here are proteins. So the idea here is that you can obtain proteins from a vegetarian diet, but the idea is that you can use more of the amino acids coming from animal diet than you can from a vegan or a vegetarian diet. So you can see the idea here, 40 to 60% of amino acids from those plant proteins. Now, in addition to this, there are a number of essential amino acids that your body cannot produce, and you have to find them in foods. And it's a lot easier to find those when you're eating animal-based protein. You have to be a lot smarter about it if you are vegetarian and collecting protein from plant sources, but it absolutely can be done. You just have to really pay attention to your diet. One of the things about proteins that's interesting is that here, if the body doesn't store the proteins at all, you either use it or you lose it. This is really different from carbs, which you can store, and fats, which you can also store. If a protein isn't used, it gets eliminated, essentially. So you're using it for a lot of different things. You see it forming the structural components of many of your body systems, but also functional proteins such as hormones, antibodies, neurotransmitters. The list goes on and on. You've gotten to know so many proteins throughout the spectrum of this course. Now, when necessary, proteins can be metabolized to form an energy source. We'll look at situations where that could actually occur. And so we look here at a nitrogen balance, and the idea here is you want nitrogen from these amino acids, the ingestion of that to equal the rate of excretion. Anytime you see more nitrogen that is not essentially being used, when there's an excess, that gets quantified as what's called the BUN, or the blood urea nitrogen, because oftentimes that shows up as urea. And we'll see how that process works later on. An individual with a positive nitrogen balance basically is seeing more protein incorporated into tissues because the body needs it for building and growing. So again, this is really common whenever you take a look at young children or even pregnant women, right? So you've got growing children in there too, or an individual like a resistance athlete who needs to continue to build tissues for athletic activity. Negative nitrogen balance itself is where the breakdown exceeds the amount that you're bringing into the body. And so this could be somebody who is eating a lot less than they used to, for example, or even in really extreme cases when somebody has starvation issues or tissue wasting disease. So of course, then we look at minerals just very briefly. So this is about 4% of the body's mass with a very small RDA. You tend to get these pretty well as long as you eat a balanced diet. They come from a number of different sources, including plants and meats. And they're important for us, helping to store things like calcium and phosphorus in teeth and bones. You see them helping to form components of enzymes, proteins that we've looked at, like the hemes essentially, and hemoglobin and the way those are assembled, even phospholipids themselves with a phospho component from phosphorus from your minerals. Your enzymes, hemoglobin, and even ionization within body fluids themselves is really important for influencing your pH. We've seen this so much with bicarbonate ions as well as hydrogen ions. And then, of course, osmolarity. So anytime you have these positive and negatively charged elements from minerals, these can actually start to influence which direction water flows between compartments. With vitamins themselves, again, a very small recommended daily allowance. The idea is these are dietary organic compounds that are necessary for metabolism. Most of them that we have function as coenzymes, and we'll see some of those in ATP production processes here in just a minute. They also are really important in visual pigment like vitamin A. Most of them are obtained through the diet itself. The body doesn't make very many of them. And of course, water-soluble vitamins can't be stored, but the fat-soluble vitamins can be. And so somebody who has lost a lot of weight really rapidly sometimes will start to see vitamin deficiencies for A, D, E, and K. You're also going to see here that antioxidants associated with vitamin C, E, and A are really important for eliminating free radicals that are produced during oxygen metabolism and ATP production. When we take a look at the electron transport chain at the end of the PowerPoint, we're going to see where antioxidants play a really big role in that process because the free radicals that are produced could continue to circulate if not bound and picked up correctly. All right, so keep in mind too that while all these nutrients and vitamins and minerals, we're looking at them as good things, that you can see disease occur with too much or too little of any of these things. And so one of the things that is associated with a lack of understanding of this concept would be somebody, for example, who gets a bottle of vitamins, and if they are not feeling well, or if they just don't think their hair is growing long enough, they take a lot more than what's advised on the back of the label. And the danger there is that, of course, you can end up with toxicity and pathology associated with a vitamin excess. So with just like so many other things, you have to make sure that you pay attention to the RDA and make sure you abide by that as much as possible. Giving you table 26.2 here, just with the distribution of minerals. You do not need to memorize this. It is only there for your reference. And same thing here with vitamins. I think this is pretty interesting stuff. I like to read through this periodically to make sure I remember where everything comes from and keep our diets nice and balanced. All right, so a couple of questions for you here. Cholesterol is classified as a type of blank. So tell me which macromolecule there. And blank, so I mean which type of cholesterol carrying molecule, blank is produced in our bodies to lower circulating levels of cholesterol by transporting them to the liver for elimination. All right, so go through, answer that question the best that you can. And then I'll see you guys back for video 3 on ATP production.